Okay, we're going to go over the correct way to write formulas when we're using polyatomic ions. And this is the practice test that has 20 problems on it. Okay, first of all, we look at our metal. In this case, it is potassium. And I'm not going to do this every single time, but just to make sure you know, we would find potassium on the periodic table. Here it is. And you notice that the oxidation state for potassium is always a +1. So I'm going to put my symbol for potassium here. Assign it a +1. Okay, that second ion is hyperchlorate. That's a polyatomic ion. You want to find that on your polyatomic ion table. If you don't have one handy, you could screenshot this one, whatever you'd like to do. I'll let it sit there for a second. There's the +1s and the -1s. And then here are the -2s and the -3s, the ones that we actually are going to be using. So, hyperchlorate, right here, ClO4. Hyperchlorate. So, ClO4, that is a -1. Now, to get the correct formula, we're going to cross these oxidation numbers. That means there will be a 1 for the potassium and a 1 for the hyperchlorate. So, in other words, we need 1 of each. So, to write that formula correctly, it would look like this. Potassium, hyperchlorate. Okay, that second one, calcium dichromate. Calcium is in the second row, second column. The alkaline earth metals. Right there, it's a +2, as there's everything else in that column is a +2, as you can see. Calcium is a +2. Ca, +2. We find our dichromate. It is Cr2O7. I'm sorry, let me get that up to the picture there. Cr2O7, and it is a -2. So, Cr2O7 -2. So we'll have a 2 here and a 2 here. Now, remember that we always simplify these ionic compounds. So we're going to divide through by 2 here and get rid of those 2's. So this one was going to look like this. Calcium dichromate. Okay, this third one has the ammonium ion, ammonium sulfate. Ammonium is our single polyatomic ion that's positive, and there it is right there at the top of the sheet. It is NH4, and it is a +1. NH4, +1. Your sulfate ion is down here in the -2's. There it is right there, SO4 sulfate, -2. So that means the ammonium, we need 2 of those, and we need 1 of the sulfate. So, if we need more than 1 of any polyatomic ion, whether it be ammonium or whatever else, we're going to put that in parentheses, and we're going to assign the subscript number outside the parentheses that says we will have 2 ammoniums for every 1 sulfate. So that's SO4. So brackets or parentheses around any polyatomics that you need more than 1 of. If you do not need more than 1 of a polyatomic, you do not put parentheses around it. Don't put a 1. Remember, we never put 1s. 1 is assumed. Okay, I'm going to move on a little faster now. I'm not going to look up every single one of these on the periodic table and show you where it is, and I'm not going to look them all up on the polyatomic ion table. So obviously I pretty much know most of these already. Should after 30 years of doing this, but anyway, so I'm going to move on a little quicker here with the rest of these, but you get the message of how all this works, but you can see how we do it. Okay, lithium. Lithium is a +1. arsenite is ASO2, and it is a -3. So that 3 is going to come down here. That 1 is going to come over here. So this one's going to look like this. Li3 ASO2, lithium arsenide. Okay, now we come to our first metal here that has more than one oxidation state. And you know most of those transition metals, or quite a few of them, have multiple oxidation states. And by that I mean simply they have more than one possibility. Now, if you look at manganese right here, it has 1, 2, 3, 4 possible oxidation states. +2, +3, +4, and +7. Chromium has 3, vanadium has 4. And so some of these we have to tell in the name which oxidation state is being used. Now, if it's something like rhodium right here or iridium right here that only has a single iridium has 2, but rhodium only has a single oxidation state, so we wouldn't put a Roman numeral in the name. We don't need to. But with gold, we do need that number because gold has more than one state, and the number tells us which one to use. So that means gold is going to be a +3 because it's gold 3. That number tells you the oxidation state of the metal right here. So that's gold, AU, and it is a +3. The chlorite ion is ClO2, and it is a -1. So we cross these, 1, 3. That means we're going to need 3 of these chlorite ions. And remember, with polyatomic, if we need more than one, we're going to put that thing in parentheses and put the subscript number outside. So we have 1 gold, AU, and we have 3 of these chlorides, ClO2, and we have 3 of those. Ammonium carbonate, okay, ammonium we just used right up here a moment ago. It's NH4. It is a +1, and our carbonate ion is in the -2s. It is CO3, -2. So we're going to cross these, 2 here, 1 down here. This is a polyatomic. We need more than one, so we're going to put it in parentheses in H4. And the 2 comes down right there. And then we have the carbonate ion. So we have 2 ammoniums and 1 carbonate. Okay, nickel 2 acetate. Once again, this tells us nickel is a +2. And the acetate ion is in the -1s. It is C2H3O2. It is a -1. So we cross here, 1 here, 2 here. So that means we need 1 nickel and we need 2 acetates. So there's our nickel, and the acetate, being a polyatomic, is going to get put in parentheses. And there'll be 2 of those. 10,4 carbonate. Okay. So this tells us that 10 is a +4. So that's SN +4. And then that carbonate ion, we just used it up here a moment ago. It's a CO3. It's a -2. We're going to cross those 2 and 4. Now, you notice here that we can simplify this. And we're going to simplify anytime we can. We're going to. So we're going to divide through by 2 here. So that'll become a 1. And that'll become a 2. So that one's going to look like this. SN CO3 2 times. Sodium bicarbonate. You've probably heard of this one. Also known as baking soda. Used for tons and tons of different things. So the sodium is Na +1. The bicarbonate ion is HCO3. And it is a -1. So this one's pretty simple. Just cross those 1s, so we got 1 of each. So that is sodium bicarbonate. Titanium 3 ferrocyanide. Okay, titanium is a +3 in this compound. Here's that funky looking ferrocyanide ion. It has an iron and then it has actually 6 cyanide attached there. So that one is a -3. So you can see 3 and 3, that these 3's are going to cancel out. So this one, the 3's cancel, so it looks just like this, TiFeCN6, titanium 3 ferrocyanide. Okay, copper 1 sulfite. Copper 1, that means copper's a +1. And your sulfite ion is in the -2s. It is SO3. So we're going to cross these. 2 comes down here, 1 over here. So this one's going to look like Cu2SO3. Uranium 4 chloride. So uranium in this compound, a +4. And your chloride ion is ClO2. That's a -1. Cross these, so that means we're going to need 1 uranium and 4 chlorides. So we got uranium, put your chlorides in parentheses, subscript out there, 4 of them. Okay, palladium 4 oxalate. Palladium is Pd, and that is a +4. And your oxalate ion is down there in your -2s. It is C2O4. Cross, cross, 2 here, 4 here. So you can see that this one can simplify. Divide through by 2 right here. So that's going to be Pd C2O4 2 times. Zirconium phosphate. Zirconium does not have a Roman numeral here because it only has 1 oxidation state. And you can see right here, zirconium is a +4. So that's going to be Zr +4. The phosphate ion, pardon me, is PO4. It is a -3. So we're going to cross these 3 and 4. So we have Zr3 PO4 4 times. Ammonium phosphate now. Okay, ammonium, that's our only positive polyatomic that we're using, +1. And then the phosphate is a PO4. Just use that right here. That's a -3. So we go 3 and 1. So we need 3 of these ammoniums. Put it in parentheses, NH4, 3 times, PO4. Sodium dichromate. Sodium is Na. It is +1. Your dichromate ion is Cr2O7. It is -2. Just that's right, -2. So we got 2 here, 1 there. So that is Na2 Cr2O7. Titanium 4 sulfate. Titanium in this case is a +4. Your sulfate ion is an SO4. It is a -2. So we go here, 2 and 4. Once again, we can simplify this one. Divide through by 2. So we have titanium sulfate, titanium 4 sulfate. Potassium cyanide, one of the extremely most toxic substances that you'd ever want to come across. K, potassium +1, cyanide is Cn, a -1. 1 and 1. So that's KCN. Very simple looking compound, but like I said, a very deadly compound for humans. What this stuff actually does, potassium or sodium cyanide, is it attaches to your red blood cells so that those cells cannot take up oxygen. So basically, it chemically suffocates you, and it does it very quickly. So you want to avoid this stuff at all costs. That would be breathing in the fumes or ingesting it in any way. Not that I think you're going to do that, but you know, anyway. All right, chromium 6 oxalate. That tells us chromium is a +6, and your oxalate ion is C2O4, and that oxalate is a -2. Okay, so we're going to have 2 and 6. All right, we can simplify here. Divide through by 2. So that's going to become a 1 and a 3. So that's going to look like this. Cr, C2O4 3 times. All right, if you've made it this far, congratulations. We're on the last one. Cobalt 3 thiosulfate. So that's going to be cobalt +3. And then your thiosulfate ion is a -2, and it's S2O3. So we'll go 2 here and 3 here. So that's going to be CO. Now remember, that's a capital C and a lowercase o. CO 3 times. And then S2O3 twice. No, I'm sorry, 3. I got those backwards. This should be a 2 here. I'm sorry. Because the 2 comes here and the 3 comes here. So CO 2 times, S2O3 3 times, and that is cobalt 3 thiosulfate.